All right, and we're back with an example of using the line of best fit. So first off, in the introduction, we talked about what the line of best fit really looked like, what it represented, like a prediction line, if you will, where the different pieces include an input and output, and then what the slope and the y-intercept really means. And then I did a quick example about how to predict the actual height when the shoe size is a certain amount. I'm going to go a little further in this next example, just throw in some items, some numbers for shoe sizes and heights. And these are just random. I just made them up. But I could ask you to find the line of best fit and then make a prediction from it, right? So there are some calculations you could do for that, but why not just use Desmos, right? So in Desmos, what we want to do is add a table. So not a list like we did before in the beginning, but much like the correlation, we use the table. And in this table, let me just go ahead and put in like 6, 8, 8, 10, and 7 for the x's. And then for the y's, it's 54, 60, 62, 64, and 59. So you see that it just kind of graphs those points there, right? And that's excellent. That's good. But what we want, that's just raw data. What we want is the actual line of best fit. Now, the way we do that, remember, it's this equation of a line is y equals mx plus b. We're going to put some version of that into Desmos, but it needs something specific. So it's not, if you notice, it says y1 on this table and x1. So it's not just going to be y and x, it'll be y1 and x1. So what I mean by that is y1. And if you just type y1, it automatically puts that on there. Now, instead of saying equal to, we want to use this tilde, this little squiggly thing, right? That's telling Desmos that it's an equation here, and we're going to use it for regression. M, and then x1, because it's not just x. And then we can just go ahead and do plus b. And if we do that, you see that it actually draws the line right there, right? So there's the data, there's a line that goes through, and that is the line of best fit. Now, the actual equation of the line of that best fit has an m of 2.363 and a b of 41.36. So I'm going to write the equation of the line of best fit as y is equal to 2.36x plus 41.36. So I just estimated these, rounded them to the hundredths. But this is the line of best fit for this data, calculated by Desmos. So if I want to use that and I want to make a prediction, if I'm looking for the height, which is the y, when the shoe size is 11, I just use my equation here, 2.36x plus 41.36. All right, so if I plug this in, y is going to equal 2.36 times 11 plus 41.36. So y is going to equal, and let me just use this calculator over here. It's going to equal 2.36 times 11, which is 25.96. So this is 25.96 plus this 41.36. Let me see, can I just do plus? Nope. 25.96 plus 41.36. I get 67.32. 67.32. All right, so that's my prediction for the height. Y is in inches. That's my prediction for height when the shoe size is 11. All right, so that's pretty straightforward. Let me go back and interpret this thing a little bit. This 2.36, that says for every inch in shoe size, for every inch of shoe size, we are expecting 2.36 inches in height. We expect 2.36 inches of height. All right, so remember, the slope is interpreted as the change in y for every 1 unit of change in x. So for every 1 inch of shoe size, we expect 2.36 inches of height.